This is the last section of the unit on congruence, and this is section 8 on medians and altitudes. So first off, a median. A median is the segment with endpoints of the vertex of a triangle and the midpoint of the opposite side. So for example, here we have a triangle. The median would be one endpoint is the vertex, and the other endpoint is the midpoint of the opposite side. So if here's the midpoint, we would just connect those two, and that would be the median. The centroid is the point of concurrency of the three medians in a triangle. So here on this little diagram, we already have one of them drawn, so we can draw on the other two. So right there's about the midpoint. So there from the vertex to the midpoint, that's our other median. And our third one, right about there, looks like it's the midpoint. So from there to the vertex is our third median. And then we have the point of concurrency. So where all three of those intersect, that is called the centroid. The centroid does have a special relationship for how it intersects each of those lines. And it's called, and we can find that out through the centroid theorem. The centroid theorem tells us the centroid is 2/3 the distance from each vertex to the midpoint of the opposite side. So what that means is 2/3 the distance of the line is contained from the centroid to the vertex, so that would be 2/3 of the distance of the line, and the other 1/3 is then from the centroid to the midpoint. This actually then breaks each line up with a ratio of 2:1. So the segment from the vertex to the centroid would have a ratio of 2, and the segment from the centroid to the opposite side would have a ratio of 1. So for example, if I were to tell you that this long length here had a distance of 10 from the vertex to the centroid, its corresponding side would have to be 5. Okay, 10 is double of 5. All right, or 5 is half of 10, but that's the relationship of each line segment when it comes to the centroid theorem. The altitude of a triangle. The altitude is the segment from the vertex to the line opposite that forms a perpendicular. So a little diagram of that. If here is our triangle, here is our vertex to the line opposite that forms a perpendicular. That would be our altitude. Notice we could have triangles that have altitudes that extend outside. So if here's my vertex, and if I want to go to the line opposite that forms a perpendicular, I'd have to extend that bottom line out to get the perpendicular. So altitudes can occur outside of the triangles. That's definitely plausible. And our last but not least vocab word here is going to be orthocenter. The orthocenter of a triangle is the point of concurrency of the three altitudes of a triangle. Orthocenters can occur outside of a triangle. They can occur on the edge of a triangle. They can occur pretty much anywhere. So let's do a diagram here. So if I start with the vertex, this top vertex, I have to go to the line opposite and make a 90. So there's one altitude. All right, so now I can move on over to another vertex. So here's another vertex. Go to the line opposite, and it has to form a 90 degree. There's our second altitude. And the third altitude of the triangle, here from the vertex down to the line opposite, there's our third one. Right there is their point of concurrency. That is the orthocenter. Now sometimes seeing these altitudes when you're kind of drawing how this one we had to kind of draw it diagonally and upwards can be a little bit difficult to do. So if you have to do this on your paper, I would suggest just rotating your paper around, and then you can draw the altitudes out a little bit easier. All right, so now we're going to do some examples using these words. First one, we're told that D is the centroid. We want to find A, B, and C. Well, the only thing special we found out about the centroid here is that it is 2/3 of the distance from each vertex to the midpoint of the opposite side. So it has a ratio of 2 to 1. And we're going to use that information to help us out. So here's A, here's 7.4, so those two go together. From Y to D, so from the vertex here, that should be twice as big as from D to V. All right, so 7.4 should be twice as big as our D to V. So it's a 2 to 1 ratio. So that means if we times this 2A by 2, it should equal 7.4. So if we take our little side, 2A, if we multiply it by 2, it should always equal our longer side, which goes to our vertex. 2 times 2A would be 4A, equals 7.4. Then to get the A alone, we would just have to divide by 4. So A here is 1.85. Okay, now let's go and let's find B. So here's the line with B. So from X to D, that's the longer side, so that should be twice as big as from D to U. So that means if we take our smaller side, our 8.7, and we times it by 2, that should equal our longer side of 3B plus 2. Well, 8.7 times 2 is 17.4, which is equal to 3B plus 2. Solve for B, we're going to have to subtract 2 first. So 17.4 minus 2 is 15.4 is equal to 3B. Then we will have to divide both sides by 3 to get B alone. So B here is equal to 5.13 repeating. Now if at any point in time you have a decimal that repeats like this, I want you to change it to a fraction. So B is 5 and 2/15. You can certainly do that using your calculator. That way we have the exact number instead of a rounded number. On our very last line here, to find C, here is our longer side, D to Z is 15.2. Our shorter side, WD, is 5C. So 15.2 is twice as big as our longer side. So we'll take 5C and times it by 2, and that should equal 15.2. 5C times by 2 would be 10C, is equal to 15.2. Then to get the C alone, we just have to divide by 10. So C is equal to 1.52. So there we use the fact that D is the centroid to be able to use those ratios or those proportions to find our A, B, and our C. This next example, we are told that PT is an altitude and PX is a median. We want to find the missing variables with the given information. So the measure of angle R is 40 degrees. So we're going to write that in as 40 degrees. XR is 2y plus 5. and Sx is 5y minus 4. And the measure of angle RPT, so right here, is 3x plus 4. So now if PT is an altitude, altitude forms a 90-degree angle. So when we follow PT down, that means right here should be a 90-degree angle. Notice now we have this triangle, and we know that the three angles of a triangle should add to be 180. We know for sure two of them, so we can figure out what the missing one should be. So here we know 90 plus 40 is 130 degrees. The three angles should add to be 180. So 180 minus 130 is 50 degrees. So that tells us that our missing angle up here should be 50 degrees. And now we can form an equation out of those two. So 3x plus 4 should equal 50 degrees. So we're going to have to solve this for x. So we're going to have to start by subtracting the 4. So we get 3x is equal to 46. And we divide by 3 to get x is equal to 15 1/3. This is again an example where you get 15.33 repeating, and we should all know that when we get those three repeatings, that is the same thing as the fraction of 1/3. So x is 15 1/3. All right, the next thing we were told up in the information is that px is a median. Well, px is a median. That means x here had to be at the midpoint. So sx should be congruent to xr. And those are these two lengths that we were given. So we should be able to just set these two equal to each other because they are congruent to one another. So 5y minus 4 is equal to 2y plus 5. Solve for y. So subtract 2y. So we get 3y minus 4 is equal to 5. Add 4. So 3y is equal to 9. Divide by 3. So y is equal to 3. So there we solved for both x and y, our two missing variables.